You.
Yo. So we're gonna continue with the physics-based UI today, and I'm just gonna jump right into it. So we have it like we now have the 2D physics plane in order. So we're transforming something from world space to the physics 2D plane, do some physics calculations, and then we transform it back to screen space so we can display it. But we still have some minor things we need to fix. with the we have a little bit of a delay from the camera, and that's like when we have a UI that's positioning itself based on physics calculations. Physics aren't calculated every frame, which means that we might go 1 or 2 or 3 frames without any physics, and that's why we can see a little bit of delay here. But I think we can do some interpolation eventually. That's not the focus today. We also have, I mean, they collide and stuff like that, but I think there's some small rotation when it comes to the collision boxes. We'll see. And right now, yeah, we're just doing square boxes, so we don't have collisions or colliders that are fit to the actual UI element they display. But what I want to fix first today is our little agent notification system. So this one, movement processing, and then we're going to see movement finishing. First of all, we see it above the object that actually called it, and for a brief second we see it here as well. So the positioning of these are not good. So let's take a look at that. So when it comes to these, we have 2 scripts in play: agent notification bubble and user interface physics-based positioning. This one is going to be the script that handles, like, the idea is that I can just take a UI element and I can slap this one on it, and we will get physics-based stuff. So while this one is handling like positioning and stuff like that, this one should handle actually displaying the correct message and things like that. And I'm pretty sure we will put the resizing of the colliders here as well. But let's take a look. So agent notification bubble has an agent notification. Just information, what is the message we're supposed to display, for how long, and so on. And it also has a display coroutine, because it's going to display it for X seconds and then disappear. UI document, new UI toolkit, and then we have a reference to the main camera currently. We don't use it in this new 2-script approach, so we're probably going to remove it eventually. So what happens in this component is that something calls display here with the notification. We check if we're currently showing another message. If so, stop showing that message. And then we set this notification to the current one. Then we calculate at what position in the world space we should make this message appear. Every agent or every entity will keep track of its own rendering bounds, and we will get it from there, and then we just offset it a little bit upwards later on. So now we just do it by the bounds, and then we set the transform of this game object to be equal to this position. So here we have one transform position equals. We then activate the game object and start the display coroutine. Coroutine will run a little bit later, I think. Yeah, I think we have it here. Start coroutine. So update first, then coroutine. So the next thing that happens, since we did set active, on enable is going to be called for this object, and what we do here is we get the background of the UI element and the content, and then we set the text. Later on we get to this display coroutine. The first thing we do is just wait for seconds And when it's done, we set this to null and hide the game object. So we change the position here. That's the only place in agent notification bubble. And then we have user interface physics-based positioning. Awake should already have happened. Here we also have a on enable and start coroutine. So this one will kick off. Other than that, we only have fixed updates and late updates. So in a frame with physics, we have fixed update first. We also have yield wait for fixed update. And then later on we have late update. So the order of execution for this component would be first on enable, start coroutine. And here we do yield, return new, wait for fixed update. So this coroutine, the first thing it does is just wait for the fixed update. So let's say that we have a frame with physics calculations. So we jump into this one, we check if we're active, we should be. Calculate the camera or viewport position, remove the Z, and unnormalize it because viewport space is between 0 and 1 on the X and Y. And we want it to be sort of world space if we want our physics to work. And then we store the previous transform position. Because here we change the position of the game object. And we change its rotation as well. Yes, and then we're done with fixed update. When fixed update is done, wait for fixed update is going to be called. So we check if it's active. If it is, then we have repositioned with physics. And we change, or we set the rigid body position to be this. So we pretty much just store the current rigid body position in this, and that is with physics repositioned. Finally, in a frame, we go to late update. If the game object is not active, we return. If it has been repositioned by physics, we change it back to kinematic and change it back to the previous transform position. This shouldn't matter. Then we get the UI element, calculate screen space position, and then panel position, and then positioning the panel. The idea is that we do these calculations not from transform position, but from the rigid body position we stored previously. So we can see here that it's rigid body position we use, X and Y. We normalize it to viewport position again. And at no point here do we position or reposition transform. Except for here then. So why does it reset to 0, 0, 0? The panel, that is. Previous transform position is set here. Okay. It works once. It should work more times, shouldn't it? No. So the first physics calculation, we get the correct position. Then we set the transform position here back to that one. Wonder if let's do this. And let's see if we get any smarter. D3. Yeah, this previous position is kind of fucked. Zero, 0.49. 0.49 is okay, and then we probably reset it back, yes. 0 on set, that's not good. This one is good. Ish. Then we destroy it and destroy it and destroy it. So what we could do is we could. So in agent notification, we do have a position. We could just relay that position to this one, but I want this one to work like isolated as well. Um, oh, you know what? Could it be? Yes. Since we have an RB, let's see here. Fixed update should be done before internal physics update. I'm wondering. If we have some movement update to the rigid body that we don't want, let's try and do this. So we just set it to kinematic here, which means that it will be kinematic here. And then we set it to dynamic here. So set it to dynamic before physics calculations. And then then after set it to kinematic. Do we want it to have an initial? Yeah, we do. Maybe. That's one thing that might be the cause of this. But no. Okay, let's just try previous transform position on enable. So we just set it on enable, and that's how we keep it. Somewhere along this one we get an update to our position that I'm not taking into account, it seems. Because with this solution, without changing this one during so by just setting it on enable and then let it be, we get some flickering. So at some point, or I guess it's this one that's flickering then. So this one. Okay. You know what? I think we're doing it. Yeah, so we do it and then we wait for fixed update. And then we do it, so it should work after the first. Yo, what's up, Cooler? A little bit worried about this one. So it's probably this one that screws us. What I see here makes sense. It feels like we play following these rules. But this one gets updated when it shouldn't. Okay. Starting to wonder if... we should choose another route. As opposed to this. It's a little bit hacky, but it would be so nice if we could make this work. So I'm always assuming this rigid body position. Yeah, this rigid body position here is calculated in the previous physics iteration. Yo, what's up, PG King? Good morning, good morning. Best case scenario would probably be to have these physics objects being positioned in a physics layer at all times. How would that work? Problem as I see it is, no matter how we do it, we're always gonna have to do something similar to this. That is setting the position directly, even though we really shouldn't. This one should always also be... Problem is that, like, in practice we have... It's dependent on so many. It's dependent on camera position and rotation. Physics calculations. Okay, we get some initial flicker. That's okay. So what with the initial flicker? Other than that, it looks good. Yeah, we need to fix this as well. That's only for the cubes, is it? Ah, for this one as well. Okay, that one is an easy fix. Let me just see. Do we have the initial flicker now? Yes, we do. Okay, so that's from the previous position, I take it. Is it not enough to do... Okay, also, I'm not that happy with that we set this one once and then let it be. It was up, Botred Gaming. We can have it like this for now. It feels like this one actually... Okay, could it be... Yes. So when we show it the first time, the rigid body position is... the previous one, and then it's just when we do the first physics calculation it actually changes position. So we could hide it until the first physics calculation. Calculate a temporary position. Portrait Gaming, how to start with Unity. It's just start. It's not harder than that. Play around. Okay, this makes me want to hide the panel before. So pretty much we show it here, and then we show it here. So maybe, just maybe, we can have a flag here as well. Then we're probably gonna show it where we had it previously. We could do a hack where we initially just spawn it way outside the screen. Doesn't feel very nice. This one. So here we set it to active. It's gonna do a late update and we're screwed pretty much. We could move the activation to the physics base, but that means that this one won't work on its own anymore. And I want to avoid that. I want the physics-based positioning script to be the one to check if it's actually active or not. I wonder what will happen if we do a flag early return, if we haven't done one physics iteration yet. And just do position Y extremely high up. Or you know... physics repositioned. If we do an instantiated flag, then I guess we disable it out here. Or we could force simulate physics iteration. Because I'm also thinking about the fact that, okay, so we have a pool of agent message bubbles. If we want to display a new message while we're currently displaying a message, we just take the old one and replace it. But if we have a sort of a flag here, we're gonna change the message for the agent bubble far away, the old one, change it first and then move it after. So that's also not a very good solution. Yo, what's up, Skafer? Good morning, good morning. How's the proc gen going? The portals? And the problem is, I wonder if this one will be called, let's see, agent notification pool, display. So we just stop coroutine here. I guess we can actually do this as well. False. And then we do, let's see, on enable. Do we have on disable? Beautiful. So in user interface physics-based positioning, here we have private bool physics instantiated. Stop all coroutines. Do I want to do that? I think so. The only problem left now is, let's see here, fixed update, fix reposition true, fix instantiated true. The only problem now is what we should do with the panel if it's not physics instantiated. We could just return here, but that means that we're going to show some UI document somewhere. Escape from a fixed room instantiation, and that's about it. Oh. have you done a lot of music composing for games, or is it like a new endeavor? I'll pause. So it's this one here I want to screw with. Not really, it's a hobby. Still nice. I mean, should we just yeet this? Style. What is this one? It's iStyle. Opacity. I don't want to fuck with transparency. Scale. Bro. Could this be it? Sure as hell hope so. And then maybe visibility is handled by opacity behind the scenes. But if we can avoid it, I would be happy. Okay, that's good-ish. I don't see any flickering. See physics-based positioning. It's beautiful. Okay, I think we are ready to do character agent instance enable, which should give us a few more messages, I think, yeah. Don't we have any physics on these? Yeah, we do. Not at all times. Interesting. I haven't done a lot of low resolution texturing, I don't think, but I have the feeling that you have to be pretty damn cautious during UV unwrapping. Yeah, I think we have a problem since we're resetting the rigid body position often. As we just allow them for a very short time, like we just allow them for one physics iteration. So I wonder if so I think the problem is this right here. Possibly. And I think rigid body position. Set. I wonder if we want to do the first time we do it with this one. The second time we just use this one. Maybe. That's right. Okay, for my character texture is 512, 512. I guess that's low resolution these days. Yeah, I know a lot of people do very smart, like texture packing. Yo, what's up, Derek? Okay, this flickering is weird. Does it actually work for these though? I'm trying to get like a physics-based UI working. So pretty much I want UI elements to appear in the game world like this, but I also want them to physically interact with each other, you know? Fuck, it's weird that this one works, but not this one. Very weird. Of course, because this one is actually position VS. Yes, this one is already in unnormalized viewport space. Okay, let's try this then. Still weird that it worked for some of the panels, I would say. Okay, get a little bit more of a might want to reset the velocity eventually. Okay, I want to get the colliders to be more accurate to the actual size. Then we might see some good collision here, because we have this here overlapping, but that's just because the collider is extremely small. Yo, this looks... fucking hell, this looks pretty good. One thing though. Oh, we have... okay, so we leave... yeah, they are not located in the game world anymore. These are, however. Okay, that's a little bit of a... yeah, that's not good at all. But the way we could do it then is... I think we can do this. Calculate this always. And then we do... Is it just a move towards we want here? But we don't only want to do this. I just want to see how this looks, because eventually we, like the previous physics calculation has positioned the rigid body somewhere because of collisions and stuff like that. So we want to take that one into account as well. Yeah. So let's do position VS. Yo, what's up, Calvino? So we need to calculate fuck, how do I want to do this? So it's basically, if we do it like this, one sec. If we do it like this, then every frame or every physics iteration we are resetting the position. That's not what we want to do. We want to take into account what the previous iteration of the physics calculated. And they hopefully calculated some sort of offset. Ay, 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 ay. Or Vision VS, world to viewport camera, blah, 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 blah. We could fixed update, physics repositioned. I don't think I want to do this, do I? Rigid body position, that's the key. I wonder if we want to do... Okay, if physics is repositioned, and here we do I'm wondering if we're gonna simulate physics interpolation here. So if we don't do physics calculations, we just transform this one according to what? What was previously, so this one, I think. Viewport camera. Position view space, position clip space, viewport to screen point, viewport to screen point. This is view space, yes. So do we have access to want to have previous view projection matrix? Yo. Do you think changing the body type while it's running is a good thing instead of just freezing the body? What are we talking about? unjittered rigid bodies. Hopefully, like we freeze it on non-physics based frames and unfreeze it on physics based frames. Calculate so like what I want to do here is, so we have a physics position, but then we have some camera movement, and I just want to adjust it like based on how the camera have moved. Okay, that's beautiful. Reposition a kinematic rigid body 2D. It must be repositioned explicitly via yeah, we have tried with move position here instead of setting the position as well. That might be what we land in. I would say that everything we do in this class is pretty unconventional. Current clip coordinates 2. Okay, is this exactly what I want to do? Like this would be a last resort. Couldn't we just do... So what I'm getting at is that our rigid body position here, it's in camera space, or yeah, view space. But then we move the view space. Which means... fuck it, if this is in view space, I wonder if we could just do some hacky thing like this. Rigid body position... view space... 553 rigid body position... world space... body position view space. Rigid body position world space. Main camera view port. That's not. Yes. It's a little bit early, I think. Okay, I guess we can do this. But we're gonna need to clean this up later on. But so when we do physics calculations, we also calculate a world position from it. And the idea is that if we haven't repositioned by physics, we reposition by world. Yes, that should work. But so instead of position VS this here, VS here, we do CS, which might mean, yeah, we might skip this later on, we'll see. Yeah, maybe. Let's see, rigid body position VS. What if we just do position CS, A little bit worried about this one. Let's see. Oh, you know what? And then later on we might want to use that position when we calculate the new world position. Yes. Let's just see how much flicker we have going on with this solution. Okay, we have it following the character. That sucks. Physics is not instantiated. Oh, viewport, yeah, that's true. But if we move the camera around, why? Yeah, is that because of the depth? Probably. Yeah, we're gonna have to keep it around. And here we don't have it anymore. Rigid body VS, where do we set it? We set it here. You know what? Oops. Rigid body position VS. So here we insert the Z again. It's very important that, like, when we set the rigid body position, that's when we don't want to use the Z. Otherwise we're gonna get some fucked physics, I guess. Maybe not, actually. Maybe it's not just taken into account. Let's just see what kind of result we have with this, so I haven't fucked it up too much. Okay. One sec. Okay. And here we just use it physics repositioned, else we just use this one. Okay, this one. Thought we would get. Oh. Yo, yes. Rigid body position VS. Oh, this is correct. But well, it's correct. Fuck me. So when we transform the old rigid body position VS, why don't we get some world space? Difference. Because rigid body position world space, that one is just calculated on physics iterations. But then we do viewport to screen. It should be okay. Mm. Okay, so if it's not instantiated, because we only changed this one once currently. We want to. I don't even want to use this one here. Let's just try and do this. Does it make sense? It does. Would love how this would look with proper colliders on them. We need to fix this, but that's easy. We can worry about that soon. That they are visible on the negative Z axis, that's not good. Okay, let's see if we can get some... Okay, I'm gonna try and clean this up a bit first, and then we can see if we can get some proper... Gliders going. Oops. So if physics instantiated, take the rigid body position vs otherwise previous transform position. That's our clip space-ish. Transform it to view space. Set position. Might need to change this to move position, move rotation. We'll see. And then we're done here in fixed update. Then we jump down to here. Looks good, I suppose. And then up here, what we do, physics repositioned. If so, change back to kinematic, physics repositioned. And here we calculate position CS like this. And why not just do this every time is my next question. Physics VS. We need it here. And we update it here because we use it here. Oh, no. We just use this one to calculate world space. We might as well use world space here, I reckon. Let's see what we get. Which makes me think that rigid body position vs Ooh, that is true. That is true. Okay, let's keep it around. Okay, let's see what we can do about the colliders. We're gonna have to dynamically resize them. Our UI elements are not changing size depending on depth from camera, and I think that's how I want it now. So we're gonna have to base it on that. So I guess we can do one sec. So we have to, okay, we have to calculate the size of the panel. We have to calculate the size of the panel because we want the size of the box collider to depend on it. We want these panels to be dynamic as well, so every time we do physics calculations here, this is where we're gonna have to resize the collider. We could get top left and top right position here. Bottom left and top right position, that would give us the size, then we would have to transform that size back down. Anything else we can do? We could initially calculate the size and then scale it depending on distance from camera and projection parameters, I guess. Anything else? I want to mess as little as possible with what we currently have. So the idea is that we just take the collider, whatever collider it is, and scale it. It can be box collider, not box done, but square collider, circle collider, whatnot. What do we have to work with when it comes to Collider 2D base class? We have, do we have scale or something? Bounds, world space, bounds. We don't have any scale, okay. Could do switch statement, scale depending on what type it is. Or we could do use interface physics-based positioning. It's making it a little bit more complicated if we want to work with any colliders, as opposed to if it was simply box collider. We can start by implementing it by doing box collider, and then I think the easiest approach is fetch panel location and transform it all the way down to world coordinates. That's world size. So before fixed update here, we fetch background something something. Or so then I guess we get that's also a little bit of a mess. Hit the box. Worldbound, worldbound, worldbound. Yeah, I want to try that one, but I'm wondering if it just works with a panel in world space. Maybe. Don't we have any collisions here? Oh, we're just using test bubble for these. Okay. Box collider. Do we have any easier approach? Viewport to screen point. Viewport. Oh, I wonder. Okay, let's do. No. Screen point to panel point. Okay, let's do... Yes, and let's do U port point to panel point. Panel, right panel. Okay, let's just see real quick if it still works, and then I want to implement the inverse of that, because we're gonna do it with 2 points, I suppose. That's rough. One sec, just gonna grab a cup of coffee. Okay, back. I'm just thinking about it. Let's make this work, see what we have, and then we can optimize it after. Panel point to viewport point. Do we have something similar? Let's see. Screen to panel. Don't we even... Maybe it's not available to us. That would suck. Screen to panel. Okay. But maybe. Okay, that's bad. So what could we do instead? We could do the easy way out. And just do a multiplication. So we calculate panel size and then we know how big it would be. So we calculate the constant between collider scale and panel size. It's a little bit... I get the feeling that it's not going to be very useful later on when we start experimenting more with shapes and stuff like that. We do have to... is it possible to... Camera screen, of course, but that's screen space. Let's see. Of course. I don't know. But let's see here. Point, screen space, screen to panel. Okay. Fuck, I don't really care about... Fuck, I do care about panel. I do care about panel position. But do we have collided to the iPanel Unity UI toolkit API? Get the fuck out. Okay, how do we define our panel? What if we just do viewport space? What if we just do... Okay, let's see if we can hack this. Okay, I guess we don't want panel. Let's do box. It's gonna be hard to get the size here as well. Contact rect. I guess we can try world bound with height. Okay. We do something like this. World bound, and then we do RB, or we do box collider size with height, but we also do See how weird this is. 1.2. It's a bit too big. Also too big. Get kinda imperfect results here, I think. And also sometimes weird world space positions. Sometimes some overlap. It's actually not too bad. So if we stop movement on this blob over there, and then we move it around, it's still sorta in the correct world position. I guess that's pretty cool. .02, where does that one come from though? .0.016. Um, reference. Has to be something defined here, doesn't it? $96, 1 divided by 96, 1 divided by 40. One divided by 0.016, 62.5. Dynamic Atlas. I don't know. Display. I'm wondering about this one as well. Too many overlap, we get like a bit more. Yes. It's not perfect, but if we could do some priority system, weight by age. Yeah, we have some jittering going on there. But I love that we can move. That we can move notification bubbles far away in the background by the ones located here, but the world position stays. I think that's pretty cool. Yeah, it's gonna need a lot of polish, that's for sure. I want to try something here. I just want to introduce a simple how would we do that? I just want to introduce a simple spring system for these. So the world position they're going to spawn in is going to be the anchor, and then we're going to have springs. These are going to have springs to that anchor, but the spring strength will decrease over time. So all of them are going to have, they want to spawn at the world position where we spawn them, or they want to be positioned there, and the force taking him there is going to be springs. Oh, fuck, I don't know, maybe. I like, also, when this blob starts walking and we get a message from it far away in the world, and then actually moving it and it sticks, I love it. We get a little physics jittering. I guess that's okay. I want to get rid of it eventually. Oh, I think the spring system might work. Let's see here. Spring to the unit. Anchor. Connected anchor has to be a rigid body 2D. I thought we could have a... Okay. Wonder if it's still... Mm. Mm. I guess it's max force. We're gonna try and I'm a little bit, let's see here, anchor point, what would that be? That would be previous transform position all the time. But then we're gonna have to do these calculations with this one as well. Add a joint. On enable we set this one. Ingenium, what's up, what's up? Appreciate it, you too, you too. Add spring joint, set anchor position, or anchor position we're gonna have to, yeah, we're gonna have to change that one here every time. We're working with here, we're working with target joint. Okay, let's see. Can optimize it later on, but basically I want to do Okay, we can put this in a function later on. Okay, let's see what actually happens here. We get the target joint. On enable, we set this. Late update, we don't do anything with the joint here. Fixed update, however, we enable it if physics instantiated, and then we set the anchor. And that's about it, isn't it? Anchor, we're gonna set target. And target, we're gonna set anchor. Max force 10,000. I don't know, seems a bit high. Auto configure target. I guess we want to disable this one. Other than that, let's go with the default. Okay, a bit too much force. Other than that, it seems to work quite well. So we want a damping ratio. Definitely 1. The problem is that we're spawning them at the exactly the same position. High range, a stiffer frequency. It's weird that we get oh, you know what? We're gonna need a physics material here. I'm wondering why we barely get any. They fly away. Okay. And never get back. Why though? Do we want to try something other than spring is my question. Wondering what this is about. I'm wondering what this jittering is coming from. It's like it's colliding with shit it shouldn't collide with. I wonder if we could go with a just gravity solution instead, actually. Maybe not. But we can't just do a world position here. That would be the best, I think. point effector 100%. Problem being that we need another damn rigid body. Then again, maybe this is better than... I like the spring effects you get. But you know what? Maybe it works with this one as well. I guess we're gonna have to explore this one more next week, because I need to run now. I guess it's okay to introduce... I would love to avoid... maybe we can... actually, maybe we can do a custom solution here. We pretty much just want to add force towards the point. Yeah, I think we're gonna go by adding force to it. I think that's good. Yeah, we can experiment with this more next week because I need to run. Still some progress today, I'm happy. Thank you so much for watching, everybody. Appreciate it. And have a good rest of the week. Peace.